Hello, today I'll be talking about the backend application, part of our project, both from the developer experience and from the artifacts that are present in our repository. So this is our backend application. The majority of this is our code. We have our application code, we have some documentation that we've written, we have some migration. This part itself comes from a library, part of the Flask framework, uses the SQL Alchemy library to create database versions. So all of this code is auto-generated for us based off of our application code. These scripts are written by us to do certain one-off tasks that are needed. So there's this init file that takes our code and registers them with our Flask application. And then there's the files themselves. This one pulls player information from two different CSVs that we have present in the repository, as well as an API. It then goes through these sources of data, pulls all the player information, and then commits that to the database with the projections, one projection for each source. We then have another script that will run through all of those projections and calculate an average for our players. And we have a section in here that we're going to be working on next sprint that will use code provided from our sponsor to calculate groupings of players based on that average. In our application code itself, we have it separated out into several files. There's our controllers, our models, and then there's some tests. This has been written with just some basic test structure to test our endpoints. Much of this is auto-generated by the Flask application itself. In our models, we have our different database model representations written in Python code. So this generates a DB connection to our Postgres database. This represents a player that has some different data sources available. And then this represents a projection from a specific source, so it has the projected points as well as the player that projection belongs to. Then in our controllers, we have our player's endpoint, so this handles any traffic coming to the player's endpoint. Currently, we have one route available, which is just the base player's route, and this returns all players that can be filtered using a few query arguments. So we've got a position and a match on name query arguments that we run through and filter the results based off of. And this is all written by us. A lot of this that you won't see in the actual repository itself is generated by Python and the Flask or SQL Alchemy library. We also have the data sets themselves that have been pulled from different sources, typically the ESPN and the Fantasy Data websites, and then we've massaged that to matching formats with the same headers so that we can easily run that through our script. We also have a requirements file. This is generated for us by the Python pip library, which manages dependencies so that we can make sure that we're always using the same dependencies. We have a README file that we have written out with information on how to run our app, both locally and using Docker. This discusses some of the information we have designated for our repository standards. So we use a tool called Flake 8 to handle linting. And this is run on our repository itself as a part of continual integration. So we're only able to merge in code once it meets the standards we have designated, which are the Flake 8 basic standards. We also have a Docker file, which builds a Docker image based on our Flask application. So it does some basic downloading of tools we need, and then it copies in some of the important files, and then runs the application itself. We also have a Docker Compose file that spins up the web container that uses that image defined by our Docker file, as well as a database container that is based off of the Postgres image. So when you are developing our application, you can either follow the running locally steps to install all of the dependencies locally and then set the necessary environment variables and get everything running. This does rely on a Postgres database to be running on that local machine, or alternatively, you can run the steps to install Docker locally, and then just run the Docker Compose commands. And as for artifacts, when we look at the repository, seeing as how this is a Flask-based web app, our repository contains all of the app code itself, as well as some CI code. This is what we use to run our CI tests and make sure that we install all of the necessary dependencies that we have. And then we also have those Docker files, Docker Compose and Docker file, so that if we needed to run this on a remote server, we could just set up Docker and run it that way. Thank you very much.
Hi everyone, let's move on to the front end of our code. Here is the code base for our React portion of our project. The vast majority of this code was written entirely by us, except of course for the package lock file that was auto-generated. You can see in our app file there exists routing to our pages, and within these player and analysis pages exist components that we will get to shortly in the user perspective portion of this video. We have a component for all the players being displayed. As you can see, we also have corresponding styling files for every JavaScript portion of this code. As for the other components, we have a footer along with the header that will display the lovely ASU image. We have a nav bar that handles, you guessed it, navigation between our pages. Along with this, we have a top player component that sorts out the top NFL player picks in our database. Lastly, for the components, there exists a charts file that graphs all the player data aforementioned. In addition, here are some of the static analysis which keep our code practices efficient and cohesive. Of course, we have our git ignore in order to keep our repository clean. Here we have our package file that holds relevant data for managing our dependencies, proxies, and scripts. Finally, here is our ever-exciting generic README for our code. Just like before, we have our UI portion of our code repository that allows for continuous integration. All right, over to the user's perspective. First thing is first, we have to get our server up and running and our endpoints accessible. The filtering via position and name is running flawlessly. We can also remove our filters and look at our entire database as well. Now for the moment we've all been waiting for, the application itself. We have the ability to graph players via the position filter, and there in the corner exists our top player feed. On the player page, we have all the listed players in the database along with the pop-up that will be fleshed out during the next semester. Another great feature we have is the ability to search directly in our app. We are right on track with our project plan and excited to continue working. Thank you all so much for watching, and we will see you again in the following semester.